Okay, and we are live. Hi, everyone. Thank you so much for joining another VJET session. I'm happy to introduce with us today Brian. Hello, Brian.
Hey Roberto, how you doing?
I'm fine, thank you so much. And today, Brian's going to talk to us a little bit about some common mistakes made in functional Java. Is that correct?
Yeah, that's completely correct. We're going to talk about functional style of programming in Java and some mistakes we saw in real life and that we can avoid now. That's basically it.
Awesome. I mean, when I was looking into the abstract and the title, I guess that you maybe already answered that, but I would like to learn a little bit more about it, which is how did you have the idea to have this session? How did you thought about it? Um, was it something like related with what you were doing, or how did you come up with it?
Well, it's actually like back in university, we had to work with Haskell, which was full pro uh, functional programming, no side effects, and with all these things that are actually making your life not easier but harder. So we did learn how to work with functional style of programming, and then I went back to Java, get it into the yeah, like enterprise kind of work. And with Java 8, you saw that people saw the new big shiny thing with the Stream API and what they could do with it.
Yeah,
And because, well, as you know, as programmers, we always read the comments and read the Java doc very, very well. Not
yeah,
people just try to do something, and we found sometimes you find out that it's not actually the way to work properly, but it does work, but it's not but it's not always the best thing to do. So I saw some things, I made some mistakes myself, and I saw some things in the pure projects I worked on, and actually these things I just bundled it and made a talk out of it. That's basically it.
okay, awesome. So, for people that are watching our stream right now, if you're not aware, we have a Slack channel that you can join. Just go to virtualjud.com and you'll see a link over there and you'll join that Slack channel. If you go to Slack, you have the live session channel that you can join. And in the live session channel, you're able to post any questions that you would like to Brian over his session. I'll be happy to relay the questions back to him. And I'm guessing without any further delay, I'll give control to you, Brian. So feel free to start your presentation.
Yes, I will try to share my screen,
Okay.
and we tested it, and it has to work like
Well, things never work when we need them. Okay, there you go.
you see my yeah, of
Yeah,
course.
we
So now let's start.
we see it.
Let's hope. Yes. Now you see it in full screen, I hope.
Yes.
Awesome. So, hi there. Good, in my case, good afternoon, or actually good evening, but I think we are all in different time zones. So, hi there would be my common greeting to you all. We're going to talk about functional Java. And the main thing is, first and foremost, Java is not a functional language, nor will it ever be. That when that has been said, let's continue because we can, however, program in a functional style of way in Java. Since Java 8, we have lambdas, the Stream API, and all that sort of things. And as you probably know, um, how people do things is not always the way it's supposed to be, or the way it is invented, or the way to properly use it. Well, if you see this guy over here, I don't know how many of you guys drive a motorcycle, but in my opinion, you can. It works this way. You can ride a motorcycle this way, but I don't think it's very well. It's actually not the way to go. I'm still wondering how this guy shifts gears because normally you would shift gears with your feet. Anyway, it's the same thing with new shiny toys, right? We as developers are kind of like little kids. If we have a new shiny toy, if I just relate to kids, say, or for instance, my little nephew, if I give him a new toy, there is one thing he wants to do, and he wants to do everything with that new toy. He wants to eat with it, sleep with it, go under the shower with it, take it to school, whatever. And that's the same thing a bit with developers. Developers see new things and let's try that. Let's make it work. But as you probably know this saying, when you have a hammer, everything looks like a nail. And it doesn't mean it's the right thing to go. I mean, we can work this way and you can say, well, hey, come on. If it's stupid, but if it looks stupid, but it works, well, it's still stupid. Let's be honest. And if you remember what functional programming or declarative style of programming is about, it's like making your code in some way more readable, doing things in a declarative way, trying to avoid all these ceremony around things we used to do. But by implementing it wrong, it probably works, but your peers will not be happy with you. And trust me, I'm an engineer is not always the way it goes. It probably works, but it can be pretty stupid. But first, let me introduce myself. I mean, some people know me, but I think the majority doesn't know me, and that's, well, quite good. I don't want to be famous or something. My name is Brian, and I work for a small consultancy company in the Netherlands. Although we work as developers, we are 20 developers in the company, and we work for other companies, bigger companies in the Netherlands, project based. So we're hired to do a project, and most of these projects are for a year or 2 years or something. And after that, we move on to another project. That's basically it. First and foremost, I'm a software engineer. With other words, I do things, I create things, I want to build things for customers in this case. All these examples I will show you today are actually derived from actual examples or mistakes, however you want to call it, and I will show them to you. But keep in mind that some way or the other, in your case, it probably can be good or bad. I will just show you some common mistakes. It's not that these mistakes are the 10 most used mistakes, but these mistakes are just very common, and I've seen them over the past few years more than once. So let's get into the first mistake, and that is doing too much in a single lambda. Okay, first of all, let's jump this out. What is a lambda? Well, I just copy pasted from Wikipedia in some way and I adapted it. But a lambda, in computer programming, a lambda expression is a function definition, which is not bound to an identifier. Anonymous functions are often arguments being passed to a higher order function or used to construct the result of a higher order function that need to return a function. In other ways, we can use a function as a parameter to another function, or we can create a function out of a function. A function as a so-called first-class citizens. First and foremost, lambda expressions are not bound by an identifier. That's the all common thing. But what's a lambda expression, or what are lambdas in Java? Well, we can consider lambda expressions in Java like anonymous inner functions in some way, just to make it easier to talk about. It satisfies a functional interface, and they only exist in runtime. And if you write a lambda expression, you can write it in two different ways. The first one is you've got an input, you've got a function arrow, and you've got an output. And the other one is you've got an input, you've got a function arrow, and you can copy paste or create a complete function body in it. So basically said, you have a single liner and you have a block lambda. Let's go to the first example of today. Here I have a small higher order function in red. It doesn't do much, but it simply is a function that takes an object beer. I'm not an alcoholic, but I just love beers. And it's a function, and the function is a function from beer to string. It takes a beer and it gives you back a string. Well, it doesn't do much, what I said. It gives you a side effect by printing something, and it gives you back the application of the function to the object. not that hard. But it's a higher order function. It's a very basic higher order function. Other higher order functions that we know are the higher order functions in the Stream API, like map and filter, for example. But just focus for this one on this higher order function. Now you see in red, by calling this handle beer function, I inserted a lambda. And this lambda is quite readable. I mean, it simply takes a beer, it gets the name, it puts in a dash and concatenates the alcohol percentage to it. Nothing more, nothing less. And this is quite readable by giving the lambda in a short notation as a parameter to the higher order function. But what you see in practice is that people want to do more and want to do more and want to do more, and they start to using block lambdas. Can you imagine that it's used, a lambda is used for inline purposes, and that you would use a lambda like this as an inline for inline purposes? I mean, people tend to smash everything into that single lambda. If else functions, try catch functions, and this one is quite easy, but it can be like nested and all sorts of things. If you give this one as a parameter to another function, I don't think your code will be more readable, but less readable. And what can you do about it? Well, let me simply show you. I have the same function over here. Roberto, is it readable?
Can you increase a little bit, please?
Of course. So decreasing.
Okay, I think it's great that way.
Okay, so what you see over here is that we have a beer, and I call the handle beer over here with this enormous ugly block lambda over here. And it doesn't make my function quite readable, right? What you simply can do is make sure it doesn't fit there. If I just transform it and I refactor it and I extract it to a method, and what it does is just, we call it name it, and it will give me a name. And you will see I just have a ordinary method, and I can call it in this lambda. And by doing so, I can remove all this crap. I can just call name it. I can move this. Well, I can even make it a, if you want to, I can make it a method reference. So by getting all of this logic out of the lambda function body and make it a method and give it a proper name, of course, because we as programmers are good in giving things proper names, right? But if you give it a proper name, and in that case, give it as a parameter to your function, you will make your code more readable instead of less readable. So what I want to say, the first mistake is don't do block lambdas, period. Well, okay, perhaps it's a bit dogmatic to say don't do block lambdas at all, because sometimes you just need to add a lock statement or something like that. But make sure that if you want to do more than one thing in a lambda, there is this old saying about separation of concerns, and it still applies over here. By separating the things properly, you will end up with more readable code, so your composition of your functions will be more readable, and you give your logic in a more transparent but abstract way, and you abstract it away from your composition. So don't do block lambdas. That's the first one. Let's go to the slide. Go back to the slides. All code examples are also in the slides, but I think it's more fun to show it than to just put it on the slide.
Okay, do you mind if I ask something?
Of course, go on.
Okay, so you recommend that we don't do block lambdas, and I agree. Is there any, so basically, will you recommend that people will basically follow any kind of rule of thumbs? Like, I don't know, if you have like a one-line lambda, it's fine, and you don't replace it. But then if you go like over X amount of lines, even two maybe, then they should extract it to a method reference. I mean, what will be your how will you pick which ones you should extract or not?
It's
Do you
very,
follow any rule for that?
it's a very good question. I think a lambda should be one line only, because you do not have the burden to return it with a return statement, first of all. But I can imagine that you say, yeah, come on, I just need to implement a second line, and well, I can say that would be okay. Personally, I'm not a fan of it. I'm like, if it's more than one line, I will abstract it into a method. But I would say if it's like 3 or 4 lines, yeah, fine, but be pragmatic on it. You'll see at this function over here, it's not readable anymore because you have nested things. But if it's readable, okay, um, just make it. I think you have to decide as a team, because normally you work in a team. What your way of coding is, just like code styling. Personally, again, I would say lambdas are single lines. That's my personal way, but I can imagine that 2 or 3 lines would be okay for you. Just make sure that it stays readable. That would be my advice. Is that good enough an answer for you?
I think so. Thank you very much.
All right, let's continue. Returning a stream, that's the next mistake. Let me get a sip of water first, because I tend to talk a lot. First of all, what is important to know from streams? The first thing is that it's not a data structure. And the second thing that's important, that it's not a data structure. Okay, now we know what it's not, but what is a stream in Java? A stream is something fuzzy, actually. It's an intermediate result which is not meant to be persistent. It's a flow of data which is derived from something like a collection. With a stream, you can create pipelines, and you can concatenate these functions that will be evaluated. And as I said, it's an intermediate result. It's like your working result. By nature, a stream is lazy. That says that it doesn't do anything unless it's needed. And if you read documentation, if you read all sorts of posts on it, they say you can transform data, but you cannot mutate data in a stream. Okay, fair enough. But if you look over here, you simply have a very simple Java stream. I have a string list, and I make a stream out of it. And I can do 2 types of functions. I have these intermediate functions, and these are a couple of examples of it. And you have these terminal functions. The intermediate functions give you back a stream, and are those, what they said, intermediate. So they give you back that work result, which are lazy. A terminal function actually gives purpose to that stream, and actually make sure that the stream does do anything. And you can collect it, you can reduce it, you can, well, get it back into a stream, you can reduce to a single value, whatever. The terminal function gives you back a data type. For instance, find any will give you an object that it's in your list. Collect, you can collect it to a list of whatever your object is at that point. There's a pretty important part between intermediate, lazy functions and terminal, eager functions, or terminal functions as it said. The point is that you can only use a stream once, because it was never meant to be persistent. So if I go to my code again, and I will get my reuse stream example, and I will increase it so you can all read it. I have at line 10, I have a list, and this list contains 2 beers. Beer is just, again, an example. It has nothing to do with my habits. I swear, really. If I call this execute function, and I have this beer stream, and I say beer stream dot for each, I simply print it. It will work perfectly, right? Let me see. You'll see that it will print my 2 beers. If I do that again, 2 times, in the same function, you will see that we will have an exception, the illegal state exception, because again, a stream was not meant to be used more than once. So it says, okay, it's already been used and you cannot use it again. By knowing this, should you ever return a stream from a function? I say don't, because for instance, I have this function over here commented, and I will uncomment it for you. And let me just remove the second line over here because it's of not importance anymore. Say we have this get beer stream, which give me back a stream. Well, if I just call get beer stream over here, everything will work perfectly, because everything I call get beer stream, and I do it once, twice, 3 times, it perfectly works. You'll see I run it 2 times and it perfectly works. But when this function is not your own, or you expose it to the outside world, you don't know what the inside of this function is. Yeah, you can decompile it, of course, so you can look into the source code, but you don't know if the stream is already used, right? I mean, if I simply say, okay, stream of beer stream is this, and I say to that stream, I don't do anything with that list, and I return the initial stream, is already consumed, and we don't know it over here. Yeah, now we know because it's in the same code base. Because if you run it, you will end up with the same illegal state exception. So I would say if you see a function that returns you a stream, you have to be absolutely certain that the stream is not already consumed, because you can't just consume it once. Therefore, I would say, if you make your functions your own and you want to expose it to the outside world, or as a library to the rest of your team or whatever, please make sure that you use a proper data type, like a list or a set or whatever. In that case, it can never go wrong in this way. You probably end up with not the correct data if your implementation is not good, but it cannot be that you end up in this illegal state exception. So please do not return a stream. The only thing I can imagine that you would return a stream is when something you return can be infinite or something. I mean, say we have this int stream, and I use an iterator, and I say from 0 to, well, and I use an iterator like this. Kind of cool. And then I just say map to object, and I want my object I beers dot. I will return it. In this case, I return an infinite stream because my iterator gives me back 0, 1, 0, 1, 0, 1, 0, 1, and it will get me the first, the item 0 and item 1 from my list. So if I call this, it will be infinite. So I will limit it to 100,000 or whatever, and you will see it will end. Therefore, a stream would be nice because you don't know how much values are in that are coming from that function. But still, just look at the practical use. How many times are you in the position that we have to use of that we can receive an infinite amount of items? I think in 9 out of 10 times you can manage with just giving you back a proper data type, like a list or something. So I would suggest, do not, the rule of thumb, do not give back a stream unless it's really, 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 really necessary. And back to the slides. So again, these examples are over here. Please don't return a stream. Are there any questions?
Well, we have a couple. So one from Raymond Klein, which is saying, if we decide to return a stream from a method, won't I already taken care of not rendering it useless?
If you return a stream from a method, yeah, I can imagine that in your private methods you will use it to construct a more concise way of coding, and that's absolutely good, I guess. But for your public methods, I wouldn't suggest you to expose a stream, because you know that code, and we all work agile of in some kind of way. Code is refactored by many different people, and a stream is not a data type. Period. A stream is not designed to be persistent. And actually, I think to give a stream to an identifier is actually a bad practice in general. So why should you return a stream unless absolutely necessary? Because you don't know if it's consumed or not. I will keep with that statement.
I guess that another example that could use from the one that you mentioned about using a stream as a return type, if you somehow are constructing a stream based on some data type, so kind of like you have like some factory methods that return you a stream constructed by some thing that you inputted, right? Kind of like you have like the stream off, right, which returns you a stream.
Yeah.
But in this case, you will have some string customized to whatever thing you need to build it, right?
Yeah, I think you're correct, but of course, yeah, Dan, you really thought this over, and that's of course a good thing. But many people, that's why I said a string is not a data type, tend to use string as a data type like a collection, and it's not, because you can just consume it once. But as you say, as for a builder kind of purposes or convenience kind of purposes, yeah, probably you can do that. But then you have a specific use case, and in most use cases, I think it would be sufficient enough to give a proper collection, and you can do anything with it. Because why would you return a stream unless it is what's the convenience of a stream? You only have to do dot stream before it, and
Yeah,
of so again, if in your private methods, I would say inside of your class, I would say, yeah, you can use it because you want to maintain that laziness. But when you move it outside, you have to be absolutely certain that it's not consumed already, and nobody will ever consume it inside your code, because then some things at the other side crack. But I think you have a good example, Roberto.
yeah. I don't want to like take so much time, but I do think on another thing that even if you don't know if the stream was consumed or not, the point is you might not even know what operations were applied to that stream.
Exactly.
So which might even make it much more difficult for you to understand what's the data coming from.
Yes, yes, I agree. I totally agree.
We only have just a comment from Nick, which is saying that we guess we can return a flow instead of a stream. That's a data type. He's talking about flow.publisher from the concurrent package.
You could. You absolutely could. I think I'm not into that package that much, but I think you could. But the point I wanted to make here, that is simply again, that a stream is not a data type.
Yeah,
If you would make it concurrent and make it and use the flow, I think that will be sufficient.
yeah. Sorry
So
about
good
that.
comment. Good comment.
Carry on, please.
All right. Um, the other thing is not consuming a stream, and that sounds pretty weird, but I just go over the basics for the people that are not into this right now, and we'll go through it fast. Trust me. Say I have a stream, and a stream consists of multiple, in this case, higher order functions, a pipeline, so-called. And imagine yourself that the first part of the pipeline is, for instance, a map function. We map the beers we had, we just want to have the names instead of the whole object. So we map it to a string. The second one, for instance, is a filter function because I only want the beers with the letter A in it, whatever. If I declare it like this, and I will just throw it into my code and I will execute it, nothing will happen because it doesn't have any purpose yet. Map, filter, and all these kind of things inside the pipeline are intermediate functions. When I give it a purpose, like I reduce it or collect it in this case into a box, and then I kick it off, you will see that the bucket of whatever it is goes through the pipeline top to bottom and will end up in a collection. With that knowledge, look at the following piece of code. If you read this code kind of naively, you will say that, okay, I have three kinds of beers. I have three beers, the Heineken, the Delirium Tremens, and the Amstel. And when I read the pipeline, I will say, okay, we have a ugly block lambda over there, which has an if statement. And if the alcohol percentage is bigger than 7, it will throw a runtime exception. Well, I tried to do this yesterday, and I'm still waiting for the result. And why is that? Because this peak function is still an intermediate function. It's a very nasty one. But peak returns a stream and doesn't return me something else. So it's lazy. By giving it a terminal function at the end, say for each, then we finally give purpose to this stream. And it will kick off from top to bottom. It limits to 10. Why? I don't know, because there will be 3 in it. We map it, and then you have the peak function. And I want to give a comment on that peak function, because the peak function is a intermediate function that can hold something with a side effect. And you shouldn't use it like this, of course. Peak is actually designed to for logging, for instance. It's a very dangerous one, and in your production code, I'm convinced that you shouldn't use peak. You can use it if you want to look inside the stream and inside a certain place in the stream how things look like, so you can print something to your console or something. But using it like this will not do anything unless you call the forEach in this case. You kick off the stream, and you will see that the first item is, as you expect, will be 5.2, and the second one will be a runtime exception. So it sounds quite silly, but sometimes people forget to consume the stream. And you should, because if you're not consuming your stream, it's like little children. If you like little children, it's like my own son. If I ask him to bring the garbage out, he doesn't do anything until I say, come on, bring the garbage out, or else you will get nothing to eat. And then he has purpose. It's the same with streams. It's a short one, but it's one not to forget. Please consume it. And then I will gradually continue to the next one, which is about mutable objects. And this always comes with a lot of discussion, and I love that. We all
Sorry,
know. Oh yeah, come on. There are questions.
not so far, just some discussions, but I'm eager to hear the discussions about the mutable stuff.
Okay, of course. Um, I'm going in this discussion from a functional perspective, and that's because of my background, of course. But if you look at functional programming, you will see this is again a definition from Wikipedia. I'm very good at looking on Wikipedia because if something is on Wikipedia, it's obviously true, right? But if you look at this definition, you will see that some parts in this definition are important, and I highlighted them in red. We work with functions. Um, avoid changing state and mutable data. A functional programming is a declarative way of programming, and it's done with expressions. That part about avoid changing state and mutable data is very important because if you look at pure functional programming, all functions tend to be pure. And I know this is not the way in the real world, but if a function is pure, or let me just do it the other way around. If an object is pure and it doesn't change state, it's very easy to argue about it. Because if we have an object and it changes state, we have to keep some sort of mental mind map of what the state of that object is and what the relationship to the function it goes into, what it does to that object. So if you look at one of my favorite scientists, Mr. Dr. Albert Einstein, he says that insanity is doing something over and over again and expecting a different result. Well, if you have a function that takes an object and changes the state and does something with that state, you end up with every time a different result. By not doing that, by having a immutable object, you can simply just ask questions about that state. And because the state doesn't change, the input and the output will always be the same, which will end up with a kind of pure function. You can do side effects like printing, which is of course impurity, but oh, sorry. It means that if I ask a question, it should not change the answer, nor should it twice. That means that if I ask you the question what your favorite color is, and you say, for instance, you say it's blue, and I ask it directly again, you can, of course, screw with me and say it's red now, but normally it would be the same. If you do that with objects, your life would be a lot easier. I mean, immutable objects make sure that you have less moving parts. It's easier to reason about because input and output will always be the same. If I give input A and output B will come out, if I do that tomorrow or the day after, it will always be the same. So there's no need to keep a mental mind map out of this. Of course, normally I get the things like, yeah, but what about performance? And the first thing what I want to say about performance is, yes, in some cases it's very you create more objects, so of course the garbage collector will kick in. But on the other hand, I think you have to look at your application or your service or whatever as a whole, and just look at what is your 3% of functions that is called extensively, and yet try to optimize that. Because most of the times we write code, and when we write code, we're all into that and it's kind of cool and it works. And 3 months after it, or when your peers try to go into that code, because your code is normally more times be read than it will be written, they have no clue what you did over there. And they have to keep in mind, okay, what happened over there and what happened over there, and the state of the object changed, and etc., etc., etc. With immutable objects, you take very much of this pain away. And therefore, they say that a stream cannot mutate. For instance, we have again the famous list of beers. And for the people asking, are these my favorite beers? Nope, not really, but it's just easy to relate to. And normally you could say, okay, you cannot set the name of a beer. Okay, perfect. So I cannot change it. But what's the problem with that? Why can I not change it? Is that because it's not allowed by the stream or whatever? Well, again, let me show you in a code example. And again, I will increase it for you. So for instance, I have the stream over here, and I would normally say I would map a beer, and I said to the beer dot set name, and I would set the name like, because feature does rule, right? Okay, perfect. But what does it say? No instance of type variable r exists so that void conforms to r. So the problem is the void. Okay, let's get into the beer and simply override my setter. Hey, I set the name and I return itself. Let's see if that works. No more red lines. Let's run it.
Can you increase the size again, please?
Like that. And what you see over here is at line 17, I will print out the new list I create. And at line 19, I will print out the original. And you see that I actually modified the original object as well, because you'll see over here, and I will increase this one as well, that for the new beers, the name is feedback rules. And for the old beers is feedback rules. So if somebody says you cannot mutate data in a stream, you can. But let's be honest, you shouldn't. That would be the correct way. You can, with some dirty tricks, you can do it. But what should you do in this case? I want to change the name of the beers and I cannot use the setter. Well, for instance, you can do this. I make a new function called with names. Okay, it's not there. Let's create it. Well, go here. And instead of setting the name, I will simply return a new beer with the name I just gave. And I understand that in this tiny example, it's very easy. I don't say it's easy in bigger examples, but you will see that in this case, and I will increase it again for you. And if I will run it now, you will see that the original list with objects stays the way they were, and we end up with a list with new objects. So now we can compare to it. Now we actually have this execute function is some sort of pure. It's not really pure because we do outputs, but it's very easy to reason about. You can imagine that if you have functions where you take in these lists and do all sort of mutations on it, and you expect the list to be in state A and it's actually in state B, it can be very hard to debug. And you find out that if you say on the far left side of your application, you change something, on the far right side of your application, something falls over. So what I want to say with this is, yes, you can mutate. Mutation is absolutely possible inside a stream. But no, you shouldn't mutate. I would say return a new copy, so you will stay stateless, and it will be easier to reason about code. And I will say if it's easier to reason about code, it's very much easier to debug code. I guess there are some questions about this topic, Roberto, or not?
Well, some people are typing, but I'll ask something myself.
Of course.
So okay, we talk about the object mutations inside the streams, and I do agree with that. And how about when we are mapping, instead of like setting stuff, we are mapping and we're changing the original list and then collecting to something else. Let's just say I want to print the names of the beers, but I'm lazy and I don't want to go and say forEach, and then I want to go to each beer and then say get name. I'll just do like a map from a beer, get the name, and I transform my stream from a beer to a stream of strings, and then I'll forEach on all of the strings and I'll print all the beers. So basically I'm mapping a list of beers or a stream of beers to a stream of strings.
Yeah, but yeah, that's in that case, if I understand your example correctly, that's, in my opinion, is that's okay, because your original list of beers stays there and isn't touched, right? Or
Yeah,
did I?
we did not change anything inside the
And
objects themselves.
that's exactly what the Stream API is tend to do. It's transforming something into something else that you can use and collect it into a new list or reduce it into a new value so you can use it again. But your original state or your original objects stay untouched. That's what's
I understand. Because now I want to overcomplicate this a little bit. That was just the introduction. Because sometimes what I see is that I see people that they start with like one object that has like, I don't know, might have like a deep graph, and then they just chain maps inside of the streams. We basically do like three, four, five maps, and in the middle of the second map, I don't even know where I am anymore, even if they don't change them. If you know what I mean.
Yeah, I can understand what I think I understand what you mean. But I think in that case you probably make your function a little bit too complicated, and you should separate it in different functions or methods, so it will be readable. Because that's the main reason why we do this. I mean, we try to do this to avoid all sorts of things that make our head go crazy, right? So
Mm-hmm.
I think I should read a actual code example with what you mean over there, and then we can discuss about it, because I'm not sure. That's my honest opinion. I'm not sure.
Okay.
I just want to say over here that you shouldn't touch your original list, because yeah, when you do that, the list is probably or can be used somewhere else, or the object is pointing to something else, and then you will end up with um, things that go wrong in a certain place of your application that is probably not what you intended to do.
Yep.
All right. So like, well, I thought it was nicer to look at a person instead of slide. So I will turn it back on.
Okay. Let's go.
Let's go. All right. Then we go into the overusing the for each, because um, for each is a function that is both implemented on a collection like a list or a set or whatever, but it's also implemented or can be called on a stream. And what you have to know about it for each is it's a terminal function, and it takes a consumer. And the terminal function says it kicks off the stream, what I just tried to explain in a few slides ago. Um, but the for each can be used to apply side effects like printing or actually changing an object. It can be used. But a for each is simply just a for loop without the external iterators like for whatever curly braces and do it inside. So normally a for each thing would be like this. And you saw Roberto, just because you hosted this session, I put your name in as well as last, of course, but still, you're important to
Oh, thank you so much.
me. So say for instance we have this list of names. We map it to uppercase and we print it, because printing is a side effect. What we can do, of course, is say, okay, now I can change my beers. That's perfectly possible in the for each method. It's designed to do so. But what you have to know is that the for each statement makes your complete statement, eager instead of lazy. And what I really, it's probably some people will laugh about it, but what I did saw in some former project batch jobs was something like this. People say, okay, we want to um, do more declarative way of programming. And I would say the for each statement is a perfect way of declarative programming, because you say what you want instead of building up a construction that does it for you, and you introduce all sorts of outside ceremony. But by doing this over here, you see the declaration of the beers, and in this case, the person wanted to enrich the objects with some findings from other data sources. For instance, it wanted to have the ratings from website A, and it wanted to have the reviews from database B. And by doing so, the person who did this did this code construction a few times. Beer.stream.forEach whatever. And again, beer.stream.forEach whatever. If you do that 3 or 4 times, what you're actually doing is taking away the laziness of the stream. Because every time you call a for each, your whole collection will be derived in that statement. You make it eager. So instead of running your loop simply once, you now run it twice or 3 times or 4 times, or how many times you use this statement. So you have to be careful with what is a terminal function and what it does to your performance. And okay, I said performance before. You have to look at what is your main 3% that hits your performance, of course. But in this time, you know that your list, and if you have a list of 10 million items, will be at least derived twice, will be at least called twice. So in this case, I would say perhaps you can make a new object, just like I showed you a few slides before. Do it in a map function, and because of that map function, you will have a stream back which stays lazy, and at the end, make sure that you collect it or you print it or whatever you do with it. So don't call the for each constantly. A little side note on this one. For people who are using the flat map function in Java 8 or Java 9, take a quick peek in it, and you will see that in that flat map function, somebody wrote dot for each, which instantly makes that flat map function eager instead of lazy. That means from that point on, that point inside the flat map is eager. And that can be a hell of a burden if you think it's lazy, but it's not. That is, if I'm correct, fixed in Java 10. I didn't see it yet, but be aware that the flat map part inside the Stream API is not as lazy as you think it will be. So keep that in mind. Next one, order of operations. And again, it looks silly, but so many people think that the order of operations is not that important because, well, it's lazy, right? So we don't know what happens. That's not true. Say, for instance, we have beers, and every beer has a brewer, and every brewer is from a country. And now I want the first 3 unique brewers' countries from the beer library as a comma separated string. If you look at the code, you probably, if you look at it simply from top to bottom, you will quickly see that the problem is in this part because we distinct over the brewers and not over the countries. And I want 3 unique brewers countries instead of the 3 unique brewers. So by pointing it over there, you will have the correct answer because now we distinct over the countries. Well, this is not a big deal, right? Because probably you will end up with data that is not correct, but it will not completely fill your system. But still, let's look at a example that will. And we will use it with an infinite stream. And I will increase it, of course. Say I have this infinite stream. And I think, okay, distinct, whatever, and I limit it to 10. And then I will perfectly print it out. Let's see what happens. Okay, that was expected. But as you look closely into my terminal, it's not ending. I hope you can see it over here, but if you look at the top, you see that my CPU is like almost 100%. It's not good.
Yeah.
It's not good. So I will kill it before it kills the stream. And the point is that I switch these two, distinct and limit. And I will explain to you why. Because this one gives you 0, 1, 0, 1, 0, 1 infinitely, right? This one syncs the stuff. So it will have, okay, 0. I didn't have that in my collection yet. 1, and I'm waiting. And the limit 10 comes. It says item 1 is a 0. Item 2 is a 1. I need to continue because it says limit 10. Item 3 is a waiting. So in that case, I will show you that by changing the limiter 1 line above to here, and of course, remove it from this part, and now run it, you'll have it the other way around. You have 10 items 0, 1, 0, 1, 0, 1, 0, 1. You distinct it, and it will actually end. This is quite of a problem if you find this out in production. But I agree. I think you guys all write explicit unit tests, right? So you will find it out instantly. But you can imagine that if I make it, I can make it even worse, because one of the main selling points of Java 8 was the streams are awesome, but we can use it in parallel. Can you imagine what will happen if I use this one over here and I will run it? It will not even give me a result. And you will see that my CPU is heating up and it's getting hotter in here, and I will stop because I think the connection will fall out if I.
Yeah, do it because we don't want to lose.
The point here is that when we use parallel, you use the common fork join thread pool. And what does the common fork join thread pool does is simply forking the part that can be parallelized, and at the terminal function, it will join again, but it will never come to the joining part because it's stuck over here. So in that case, it will not end up giving you at the end a result at all. So you see that in this case, we have two problems. The first problem we have over here is, well, I will show you infinite streams, yada yada, forever. First of all, the solution to this is, first of all, look closely to the order of operations. And we have to prevent incorrect answers. That's quite obvious. But typos can be made, bugs can be introduced, everybody makes mistakes. The second thing we have to do is making sure not to overly use infinite streams. Only use it when absolutely necessary, because infinite streams can make things more complicated than you think. And if so, I used an iterator over here, a Java 8 iterator. But most of the times, if you want to use an int stream or whatever, use the range or the range closed. So you are certain that you have a limited range and not an infinite stream. I think 9 out of 10 times again, you can handle your stuff with these things. And if you need to use an iterator, please make sure that you have a terminal function in it, or in this case, a guard. From Java 9, there is a new iterator that you can give a guard in it, a Boolean function. So you can make sure that your iterator stops properly. So again, make sure that the order of operations is correct. It seems quite okay when you quickly review your code, but on the other hand, if you use this in combination with infinite streams, it can end up in a pretty disaster.
Mm-hmm. So for that example you were showing us earlier with the limit and the distinct,
Mm-hmm.
If you will set, for instance, limit to 2, then it will mean that the stream will complete.
Yeah. I can show you, of course. I can show you, of course. You say that, okay, well, I will remove the parallel over here.
Yeah.
And you said if I set the limit to 2, it will end,
Yeah.
right? It will terminate. Yeah, it will.
Yeah.
Look, if I set the limit to 2 and I will run it, you will see it end over here. You see process finishes.
Yeah. Even though probably it was not what we wanted, but basically meaning that we might have like some code that that we think that's working, but it's actually not.
Exactly. It is accidentally stopping now because in this case we know that our iterator is only giving me 2 distinct options, and I limit it with 2. Limiting with 1 will also kill it, but if I make a limit 3 out of it, it is more than the iterator can give you, and in that case you will see again that is not responding anymore. So the order of operations in this case is important, that you first limit and then distinct instead of first distincting and then limiting. And again, the iterator is pretty silly over here, of course, but you can imagine that in real life situations you can end up with pretty strange effects that you didn't expect on forehand. I want to do, I guess, 2 more mistakes, and then I think, because we are running out of time. And
yeah, we don't have much time left, but I mean, if you can make that quick.
I can make it quick. I will go to optional, because that one is quite nice. Optional. Optional is what they say. It's actually the implementation of the maybe monad. And normally people will like go away and scream at me and yell at me, but monad is not that important. It's just an encapsulation. It tries to encapsulate the possibility in this case of the maybe monad is that it tries to encapsulate that a value can be null. Nothing more, nothing less. It can be empty. So you can simply consider it a wrapper. And we all know that because we used it, right? Why the optional? Simply because we want to force our users to look into the optional instead of simply using the object and end up with a null exception. So you probably think that optional is empty or optional is filled. But the first problem comes over here. You can set an optional to null. And that's a big problem, because now we have the same problem again. It can be null. So let's discuss here and let's agree over here that you never, ever, ever assign an optional to null. And then we do not have the problem anymore. I think that's a good agreement. From an optional, you need to unpack it. And if you want to unpack it, you use the get function. But the get can give you a no such element exception, because if it's empty, you cannot get anything. So what you see in code normally is that people tend to do this. They write a guard around it with is present. And please, people, tell me why you do this, because how is this in any way more convenient than just a simple null check? I don't think it is, because you have the same code construction. You need to guard it with something. Therefore, there we have something else, an optional. We have something like the if present and the map function. If present only works when something is present, and the map function only executes when the optional is filled. But that's just one part of the question. What if we want to do something else? Say we want to have an alternative flow, like with three options. We have the or else get, and the or else throw. And I will do this in slides now just because of time. If we do this over here, this is quite obvious. We have a function, or we have a maybe over here, of an optional, optional called maybe string, and we map a function run if exists, or else we throw a runtime exception. It's quite obvious. I think this is the most obvious one. But then we have the or else function. Normally, if you would read this, you say, okay, I have an optional, I map a function on it, or else I will run, in this case, the run if empty, and I will print it out. If you would read this, you will think probably that at the end it will print out foo, because the optional is filled with the string foo, right? But if you run it, you will end up with this in your console. First of all, it will give you only run if optional is filled, and then it will also give you only run if empty, and then it will give you foo. So my end solution is okay, but what you see is that my run if empty function is also evaluated, and that's pretty weird, or counterintuitive in my opinion. I expected that it would be like short-circuited, and that because the optional is filled, or else wouldn't be evaluated at all. If I want to manage that, I have to use another function, and that's a third option, and that's the or else get. And or else get takes it must be used in this way. And now we'll see that or else get, the run if empty, is only evaluated, is only called, because it's a producer, it's only called when the optional is actually empty. So by running this function, you will have only run if optional is filled and foo. And that's actually what I expected when the first time I used it, and I used the or else function, and I found out that my else part was also evaluated. And that can be pretty devastating if, for instance, you want to do logic on it. Say, for instance, you have a database and you want to create a new user if it doesn't exist. And if you use the for else function, you know that it will be evaluated now. So what you end up with, if a user does exist, you will end up with or a collision in your database or a duplicate value, which in both cases is not what you wanted. So to conclude this one is when using the or else, you have to make sure that it has no side effects at all. Or else is actually only meant to give you a default value. So I want to have a default string just as a string inserted if the optional fails, which is quite okay. If I want to have an alternative flow with logic in it, please, please, please use the or else get. The distinction between the two is doesn't look that much, but in practice, it turns out that many people, at least once, came to the conclusion that they fell through the problem with using or else instead of or else get. Do I have time for a last one, Roberto?
Yeah, sure. Go ahead.
All right. The last one will be about exceptions, and I think this one is pretty interesting. For those who think what is there on the sheet, it's the Ariane 5 project from the European Space Agency in 1996. And the Ariane 5 had the problem that an exception was thrown inside the software and it blew up. And why was that? Because the velocity was converted to an int value. And as we all know, an integer can hold so many values. And in the beginning, it goes out fine, but at a certain level, the velocity was bigger than an int could carry, and we ended up with an exception. And then the whole system froze, and you see what happened. So exception handling is important, right? But if you want to use functions with checked exceptions and lambdas, it's not possible. Say, for instance, we have this function do something that throws an isEmpty exception. And of course, in this case, isEmpty exception is a checked exception. You are not allowed to use this inside a lambda. What you can do is use this ugly part of code. And then we come back to the first thing, we're using a block lambda with a try catch and whatever. It works, but it's not very pretty. Inside the lambda, we simply do a try and catch, and we throw it into a runtime exception, and we find out that it works. Okay, fair enough, but it's not pretty. So how can we do it? What we can do is we can wrap it into another function. And this is, if you really want to catch the function, this is probably, and you want to do something else with it, this is probably one of the ways to go. You wrap it into a method, as I showed you in the first part, and then we can still use it. But again, it doesn't feel quite okay. Okay, of course, when you use how do you call it? When you use Project Lombok, you can do sneaky throws, but I'm not going into that. What we can do is create an own checked interface, checked function. In this case, it's a copy of a normal function, but it can hold a function with an exception. And yes, in this time, I also wrote a ugly block lambda with a wrapper function, but I will slightly put it into a library, put it far, far away inside my system, and I will never touch it again, I promise. So, but doing so, and now it fits on one slide, that's one other purpose. By doing so, I can wrap the function into with a wrapper I just created, and make sure that every exception, what's over here, is transformed into a runtime exception. And I think that's one of the ways to go. Why I simply hate checked exceptions. I think they're useless, but that's my opinion. But there still is a problem over here, because inside a function, when a runtime exception is called, it will terminate my stream, and that's something I do not want. I think we have to carry on with that stream and just accept that something that goes wrong or has another value is data as well, and at the end resolve it, because I want my stream to finish, because perhaps my second item in my list gives an exception, but the third item is good and I don't want it to kill it all. If we look at functional programming, there's one thing I'm missing in Java, and that is the either type. And I just give you a this is a very naive, small implementation of either. An either type is just like the optional type, a wrapper type. And it can either be left or right. It cannot be both. So by default, normally you use the right for the good values and the left for the incorrect values. So what we can do now is we can make sure that our exceptions are not exceptions anymore, but are either's. And we end up with a list of either's instead of killing it with an exception. If we call this function, and in this case, I actually wrapped the exception into the left part, but you can wrap everything in it. In the right part, we give you the solution that is actually something worth to us. By doing so, we end up with a list of either's with lefts and rights. And by filtering this list out, we can do with it. We can only use the good parts and work on that. We can use the bad parts and retry them, because in either left, in this case, I put it in the runtime exception, which is probably pretty naive. But you can say, okay, something went wrong, and I give you the original integer, or I give you the original input as well wrapped in an object, so I can retry, for instance. But the most important part by using this wrapper function is that your stream is not killed. Your stream will end, and you will end up with a collection, and then you have to handle it yourself, like this. I want to show you one more thing, and that's again for the either type, or for the exception handling. There's also a library, and this library is perhaps known to many of you. It's favr. It's formerly known as Java slang, and yeah, because of patent rights, you cannot use the word Java anymore, so Java slang had to rename to favr. And what you see over here is that favr has the either implementation. I implemented the either as well over here, pretty naively, but it's quite simple to implement it. But favr has it as well. But what favr has more than that is the try. And the try is actually you can imagine it yourself as an either type with, on the left side, an exception, and on the right side, the correct value. And they call it a fail or a success. If we look over here, we have a function that randomly throws an exception. Takes a string and randomly gives me an exception. All right. So if I run this, I have my teams over here, and this is the teams I work with: Team Alpha, Bravo, Charlie, Delta, Echo, Foxtrot, and Golf. And I map my I do this. I lift it into a try. And that's the important part. It's quite easy. So what you end up with is, instead of a list of strings, or it will be cut off when the exception is thrown, you will end up with a list of tries. Let me show you. If you look at the output, you will see that the first two failed. The second two succeeded, and the last three failed as well. And of course, because my function is randomly throwing exceptions, it can go wrong. Something else can go wrong the next time you throw it. But because it is a success or a failure, we can handle it afterwards. By doing so now I'm doing something wrong. By doing so over here, I simply take that output I created and I filter the failures, and I want a stack trace of it, for instance. And I can do the same with the good parts. By doing so, you'll see that for the failures, I end up with an exception, and it will give me the stack trace. It doesn't say anything to me, but you'll see the point of it. The point is that we have to shift the paradigm from, oh, there is an exception, we have to catch it immediately, by it's a stream of data. The stream of data is lazy, and we can use an either or a try or whatever to wrap it into something else, and at the end, filter out what we need. If we want to keep the good solutions, We can keep them. If you want to do something with the bad solutions, the failures, we can do so. The try only gives you exceptions. It can handle exceptions. And if you want to have more, say I want to, if something goes wrong, I want to transform it, or I want to have, say, for instance, my original value in it, you can use the either type, because that is more general and can actually hold anything. I think I will conclude with this part. I, of course, have some more material, like always. I'm running out of time, I see. And I guess there perhaps are some questions. First of all, I will show you my end slide with my name on it and the company I work for, because, hey, free advertising, right? If you want to if you have questions afterwards, please ping me on Twitter. No problem. At Brian Verm is my Twitter handle, or email me Brian@brianvermeer. And perhaps you want to ask questions over now, or want to ask questions over now. Roberto is monitoring them, so I will switch back to my normal camera if I can manage that.
Yeah, some of the questions that were being asked, I already being asked them during the session. Um, there, you have a colleague over here called Nick.
Yeah, it's one of my colleagues. True.
He says I.
Hi, Nick. Thanks for joining in.
Yeah. Um, well, we got the question during the session, so I since we're not out of time, I think we're gonna skip that part. But as you said, if someone wants to reach you out for any additional question, they can go and tweet to you
Yeah, of
directly.
course. You can always tweet to me. I will not say I have an answer for everything, because yeah, I'm not the almighty programmer, of course. But perhaps we can come up with a solution that is good for you, or I can just answer your question, or we have to investigate in sometimes.
Yeah, wonderful. So thank you so much for joining us today for this video section. I hope that you had some fun. Um,
I actually had some fun. It was pretty weird to do it so with your own screen. I'm glad you were on the background and that I can hear you once in a while. But
mhm.
I have no idea how many people were actually watching. But
Oh, we had over 200, so it
oh
was
wow,
very very good. And when we're done, the session will be directly available on YouTube on our channel, so you can watch it right after.
yeah, yeah. I have more material, of course, and I think I can talk for 2 or 3 hours about all this stuff. But I hope I inspired some people. I also hope that some people say, well, I don't do this, I already know this. Then I'm glad we have good programmers in within the VJUK in that case. So
Very well. So once again, thank you so much for joining us, and of course, thank you so much for all our audience that took some time off to be here with us. Stay tuned for our next session. So go to virtualjug.com or our meetup webpage to check out the sessions we're going to have next. And without anything else, I'll say goodbye to you, everyone. So bye bye. Thank you so much, and see you next time.
thank you. Bye.
Bye bye.